Launched into low Earth orbit on Tuesday the 24th of April 1990, the Hubble Space Telescope is one of NASA's most successful and long-lasting missions. In this video, we're going to follow Hubble's journey from its inception right through to its launch into space and its incredible missions and discoveries along the way. The origins of Hubble can be traced back to the 1940s, when Lyman Spitzer, a researcher and professor at Yale University, published a paper entitled The Astronomical Advantages of an Extraterrestrial Observatory. In it, Spitzer argued the benefits that a space telescope would deliver over ground-based observatories, chiefly the need to overcome the refraction effect of the atmosphere. The refraction effect blurs and distorts light from stars. This creates the optical illusion that gives stars their twinkle. Further, ozone and gas atoms and molecules in the atmosphere absorb ultraviolet light and X-rays emitted from high-temperature phenomena in space, limiting the information received by telescopes and instruments on Earth's surface. Spitzer theorized a space telescope inserted into low Earth orbit above Earth's atmosphere would overcome these obstacles. Spitzer's paper was not broadly distributed and largely went unnoticed by the scientific community for over a decade. Though, as Spitzer himself acknowledged, the greater effect of his research was to convince himself that the concept was theoretically achievable in his lifetime. Fortuitously for Spitzer, the onset of the Cold War in the 1950s saw the Soviet Union and the US attempt to establish dominance in spaceflight capability. Known as the Great Space Race, this competition led to the achievement of many significant astronomical milestones, including the launch of the world's first satellite into low Earth orbit, Sputnik 1, in 1957, and the first human, Yuri Gagarin, to enter orbit in 1961. These achievements, both delivered by the Soviet Union, were symbolic victories over the US, with Western media stoking public anxiety and fear that national security could be at risk. The effect of what was later termed the Sputnik crisis was to garner nationwide support for President Eisenhower, and later President Kennedy and Johnson, to establish agencies like NASA and DARPA to drive investment and development in scientific and astronomical initiatives. By the early 1960s, NASA had already completed a number of experimental space missions, the most significant being the manned Mercury and Gemini spaceflights. In 1966, NASA launched its first ever orbital astronomical observatory, called OA-01. This was the first of 4 planned experimental space observatories, designed to test the manufacturing and deployment of optical equipment in space, and would prove to be the precursors to Hubble. Fresh off the launch of OA-01, the US National Academy of Sciences approached Spitzer to produce a paper demonstrating the scientific benefits of a large space telescope. The paper was published in 1969, with the intent of gaining support from NASA and obtaining federal funding. Despite NASA agreeing the concept was feasible, the significant cost of building Hubble, initially estimated at $400 million in 1969, generated significant resistance from Congress and was originally denied in 1975. It was only through intense lobbying by NASA and leading astronomers led by Spitzer, and through modifications to the original design to reduce cost, that led to Congress approving the project in 1977. With funding secured and a target launch date of December 1983, design and construction of Hubble began in earnest. Work on Hubble was divided across NASA departments, with its design, development, and construction undertaken by the Marshall Space Flight Center, while the development of the scientific instruments and the ground control center were given to the Goddard Space Flight Center. Some work was outsourced to contractors, including Lockheed Martin and PerkinElmer, while in an attempt to reduce skyrocketing project costs, the European Space Agency was engaged to pay for and develop the solar array required to power Hubble in exchange for a timeshare of the device when it became operational. The construction of Hubble and materials used were unlike any previous space observatory, given its scale and broad range of observational requirements, in addition to the durability required to withstand extreme temperatures in space. Given these significant scientific and technological challenges, Hubble spent the best part of 20 years in development, before its launch in 1990, 7 years behind its initial target launch. In total, the initial budget of $400 million, estimated in 1969, had blown out to over $1 billion at the time of Hubble's launch. Three different types of light measuring instruments are installed on Hubble, including cameras, spectrographs, and guidance sensors. Hubble's two cameras are the Advanced Camera for Surveys and the Wide Field Planetary Camera. Both cameras work in unison to capture astronomical objects across a broad range of wavelengths and a large field of view. These cameras are what produce the popular images of nebula and faraway galaxies that so many are familiar with. Hubble's active spectrographic instruments include the Space Telescope Imaging Spectrograph and the Cosmic Origin Spectrograph. These do not capture images, but analyse the wavelengths of light emanating from different celestial objects to measure their chemical content, temperature, density, and motion. Finally, the fine guidance sensors on Hubble provide high-precision pointing information used to lock the telescope onto specific celestial targets. The FGS uses interferometric technology to provide more accurate readings. The size of these instruments, ranging from a shoebox to a telephone booth, were designed to be easily accessible by astronauts for servicing using wrenches and power tools. Over the years, Hubble has been orbiting Earth. 4 servicing missions have been completed to maintain, add, or replace critical components and instruments. The first servicing mission, completed in 1993, aimed to replace the faulty primary mirror in the Wide Field Planetary Camera. A manufacturing defect in the grinding and polishing of the mirror during Hubble's construction led to the low-quality images sent back to Earth. Over 11 days, corrective optics were installed by astronauts, requiring 5 consecutive spacewalks, the most ever completed at the time. The most recent servicing mission was completed in May 2009. This mission saw the third iteration of the Wide Field Planetary Camera installed, along with the Cosmic Origin Spectrograph and the Soft Capture and Rendezvous system, which will enable the safe capture of Hubble when it is decommissioned in the future. The significant cost and risks associated with these missions and the retiring of NASA's manned shuttle program in 2011 mean future servicing missions are unlikely, leaving Hubble on its own to stand the test of time and the rigours of space orbit. Hubble has been used to help resolve long-standing problems in astronomy while also raising new questions. Findings from Hubble improve the accuracy of the expansion rate of the universe, and therefore predictions of its age, by measuring the brightness of faraway Cepheid stars. It allowed us to map the clustering of dark matter distributed across the universe by observing its effects on other stellar objects. Hubble also improved our understanding of seasons on other planets by tracking and observing weather patterns in their atmospheres. Recently, the 3-year Frontier Fields Initiative, led by NASA and the European Space Agency, directed Hubble towards deep space to reveal galaxies formed temporally close to the Big Bang, never before seen with the human eye. Hubble's discoveries allow scientists and the layperson alike to visualize phenomena in space and provide evidence for theories that would otherwise remain hypothetical. Since its launch in 1990, Hubble has orbited the Earth 130,000 times, covering 3 billion miles, has taken over 1 million images, and observed over 40,000 different celestial targets. NASA is confident Hubble can continue to operate well into the next decade. Demand for Hubble's observational capabilities remains strong. In 2018, requests to use Hubble for research outweigh the available time for observations by 5 to 1. With the launch of its more advanced successor, the $10 billion James Webb Space Telescope, planned for 2021, Hubble will continue to be an invaluable tool for astronomical research well into the next decade. Ultimately, Hubble's legacy will continue well beyond its operational life. Those that contributed to its inception, development, and ongoing missions were pioneers in aerospace engineering and spacecraft design that lay the foundations for future stellar achievements. While photos of Hubble's discoveries continue to adorn bedroom walls and school labs, it will continue to bring the wonder of astronomy and space into the conscience of generations. Thanks for watching. Please don't forget to like, subscribe, and turn on notifications for more Factopia content.